Hello everyone, welcome to today's 2.3 Day 1 Notes, Factoring Quadratics when a equals 1. To get started, we have a factored form here, and the directions are to multiply. So, quick reminder on distributing, we're going to use our arrows to do that and then combine like terms. So please press pause now and give this warm up a try. Remember, the shortcut for pressing pause is the space bar. Please press pause now. All right, let's check answers. How did we do? I got x squared plus 5x minus 14. Hopefully we match. If something went a little sideways, no worries. Press pause again and let's check our arrows, check our signs, and how we did combining like terms. Now that our brains are warmed up with how to distribute, let's now discuss our key learning for today, which is factoring a quadratic trinomial or binomial with a missing b term when a equals 1. So let's highlight this title so it stands out in our notes. And today is all about when a equals 1. What do we mean by that when we say a equals 1? Remembering our standard form of a quadratic in standard form is ax squared plus bx plus c, where we have a, b, and c. So we're talking about cases when a equals 1, when we have a trinomial, right? This is 3 terms. Or if we had a binomial with a missing b term. So imagine, don't erase, but I'm going to show you what I mean by that. If we had this situation, so now that would be a binomial with a missing b term. Those are the cases we're going to look at today. To factor the polynomial or undistribute, remember factoring is connected to this idea of undistributing something, we will find factors of the c term that add to the b term. We can verify by distributing the outer and inner terms remember that concept of FOIL, first, outer, inner, last. That's that idea of doing what we're talking about right here, to check the b term. I'm going to put that last sentence in parentheses. It's an optional step, that verifying step. So the key phrase we're going to use starting today, if I had to summarize this in one phrase, when a equals 1, we need factors of c that add to b. And please highlight this. Notice I even kind of wrote it on the bigger side so that it stands out. This is the key learning for today. This is what we're going to be practicing. When a equals 1, factors of c that add to b. How to work on a binomial with a missing term, b term, we'll talk about that in a little bit. So when we have a trinomial, quadratic trinomial, this is the key here. Factors of c that add to b. We have an important note here on paying attention to the sign of c. I'm going to kind of abbreviate here. When it's a positive C term, and again, when we say C, we're talking about this right here. So when we have a positive C term, signs of factors are the same. Both positive or both negative. When C is negative, signs of the factors are different. One positive and one negative. So right here in this box is the mental conversation we're going to work through as we practice. And if some of it's like, whoa, what did I just write down? No worries. We're about to start practicing now and putting it to work. And then this will be a home base as a reminder for the conversation on how to factor when A is 1. So let's look at our first example to start putting all of this in perspective. The directions are factor the quadratic trinomials, and we have x squared plus 8x plus 12. So this is a quadratic, right? Power of 2, trinomial, 1, 2, 3 terms, and A is 1. There's an invisible 1 right there that we don't write. In fact, for all of these, notice A is 1. These are all the same case. So let's go back to our conversation and apply it. We need factors of C that add to B. Factors of C that add to B. So let's talk about that. I need factors of a positive 12 that add to 8. So for this first one, let's actually write that down. So for number 1, we need factors of a positive 12 that add to a positive 8. Remember that factors are two numbers that multiply to be this. So if it helps, let's talk about what multiplies to 12. So I could talk about a positive 4 and a 3. So 4 times 3 is 12. But if I add them, 4 plus 3, I do not get to the 8 that I need. So you can leave it on the list, but like maybe we just kind of cross it off. What else multiplies to 12? Well, 2 times 6, 2 and 6 are factors of 12, right? 2 times 6 is 12. And then when I add them, 2 plus 6, I get the 8 that I need, right? Now notice, this is positive. This is a positive 12. So now let's put into perspective this note about the signs of C. If C is positive, both of the factors have the same sign, either both negative or both positive or both negative. Why? A positive 2 times a positive 6 is a positive 12. A negative 2 times a negative 6 would also get me a positive 12, right? Negative times negative is a positive. But to make that decision, we have to look at what we're trying to get to. I am trying to get to a positive 8. So I want this 2 and this 6 to both be positive. So our factored form is going to be x plus 2 times x plus 6, and we are done. So I take the factors of 12 and I use them to write the factors of the quadratic, x plus 2, x plus 6. And remember that little note we wrote in parentheses, you could verify by distributing, like mentally or physically, use arrows to multiply this out, and you would end up right back where we started. Let's try number 2, n squared plus n minus 6. So for number 2, just to keep the little conversation notes going, we need factors of negative 6 that add to a positive 1, right? There's a 1 right here that's just not written. So factors of C that add to B. factors of negative 6 that add to a positive 1. I would first just have a conversation in your head about what multiplies to get you 6. So I could be working on 6 and 1, right? 6 times 1, that is 6. Notice this is negative. So when C is negative, to multiply to a negative, 1 has to be positive and 1 has to be negative, right? To multiply to a negative 6. Well, if this is negative and I add those together, that's a negative 5. No good. I'm trying to get to a positive 1. If I make the 1 negative, 6 plus negative 1 is positive 5, still no good. So no matter what I do, 6 and 1 is out. What else multiplies to get me 6? Well, I could work on maybe 2 and 3. 2 times 3 is 6. Now, this 6 is negative, so one of these has to be negative. What if I have 2 be negative? Negative 2 times 3 is the negative 6 that I need. And when I add these together, right, factors of negative 6, have those, that add to a positive 1. Negative 2 plus 3 is the positive 1 that I need. So my factored form is going to be n minus 2 times n plus 3. Notice, I'm literally taking these numbers, dropping them in, and I'm done. That is my answer. N minus 2 times n plus 3. Number 3. A is 1, so I need factors. Actually, I'm going to move this. It doesn't get in the way. Let's put it up here. Factors of negative 36 that add to negative 9. Factors of C that add to B. So off to the side, let's start considering factors of 36. The first one that comes to mind for me is 9 and 4, right? 9 times 4 is 36. But this is negative, so one of these has to be negative to multiply to get to a negative 36. No matter what I do, that's not going to help me out here, right? It's either going to get me 5 or negative 5, so that's no good. 9 and 4 is out. What else multiplies to get you 36? 6 times 6. That's not going to help me, right? Because if one of these is negative, add them together, that's a 0. So 6 times 6 is out. What else? What else might work? How about 12 and 3? 12 and 3. If 12 is negative, negative 12 plus 3 is the negative 9 that I need. So my final answer here for the factored form is going to be x minus 12 times x plus 3, and I am done. So this is really this whole process of factoring when a equals 1 is also a fantastic practice for our knowledge of multiplication. Like what multiplies to be what? What are my factors of 36? And that comes with practice, and we're going to have a lot of that today. Nice job. Let's take a look at our next example, number 4. And this is our first example. If you'd like to label this one, remember how we said we were going to talk about a binomial with missing b term. Binomial with missing b term. That example is going to be number 4 right here, right? Remember, it's ax squared plus bx plus c. So if I have a missing b term, I am now down to a binomial. Ax squared plus c, that's a binomial. And a is 1 in this case, right? There's an invisible 1 right there. So let's talk about this using the note box over here. Example 4 is called a difference of two perfect squares. And sometimes people abbreviate this D, difference of two squares, D2S. If you like that abbreviation, difference, that's a D. Kind of looks like an O, sorry. Difference of two squares. Difference of two perfect squares. So let's highlight this so it stands out in our notes. Difference of two perfect squares. What do we mean by that? The A and C terms are perfect squares. What are our perfect squares? Remember, our perfect squares are 1, 4, 9. Where am I getting this list? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and the list keeps going. 36, 49, 64, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 81, 10 squared, 100, 11 squared, 121, and the list keeps going. Here's the key. So this is the first bullet. Second bullet here, bullet point. The factors will be identical except opposite signs. Where the A and C terms are square rooted. All right, so just like before, we have our conversation now here in this note box. Let's put it to work. So I have a binomial, right? Two terms. One, let's put that 1 back in here. 1 x squared minus 4. 1 x squared minus 4. A and C are both perfect squares, right? 1 and 4 are on this list. So to factor them, we need the square root of 1 and 4. The square root of 1 is 1. So I've got x, 1x, 1x. The square root of 1 is 1. So 1x, 1x. The square root of 4 is 2. So that's 2, 2, right? Here's this bullet point. The factors will be identical. Notice these are identical, except opposite signs. So one of these is a plus and one of these is a minus, and we are done. So my factored form is x plus 2 times x minus 2. X plus 2 times x minus 2. Let me put one more here for an example. Make that box a little smaller so I can fit another example here. Oops. There we go. I'm going to change the color so it stands out. I'm going to put it in purple. Here's another example. What if I said 64x squared minus, let's pick another one on the list here. 9. 64x squared minus 9. 64 and 9 are both perfect squares. Oh, and then a key piece here. We're talking difference, right? Difference means subtraction. So the key is that you're subtracting these. If this was a plus, none of this would apply. It's only when it's the difference of two perfect squares. Okay, so now that we've established that this is the difference, right, subtraction, difference of two perfect squares, the factors will be identical except opposite signs where A and C terms are square rooted. So let's get to it. The square root of 64 is 8. So I have 8x, 8x. The square root of 9 is 3. Again, for emphasis, factors are identical except opposite signs. So 8x minus 3, 8x plus 3, and we are done. Now this example, technically A is not 1. That's okay. The difference of squares, this could be 1, this could be 36, this could be 81. The difference of squares. In our notes, just to highlight which ones those are going to be, here's that special case. And here's that special case. Because we're technically right now in A equals 1 land, that's why both of these just have A equals 1. But I wanted to put this one here because this is also where we're headed with the difference of two perfect squares. All right, nice job. Super important note, make sure you highlighted that. This is going to come up starting now throughout our factoring practice. Let's keep going with our practice. So I've got 5, 6, and 7. I'm going to work on 5, 6, and 7 with you, and then you're going to try 8 through 13, right? Number 5, z squared minus 11z plus 18. So starting with this one, we're not going to write the sentence anymore. We're just going to say it out loud. And this is what would be hopefully the thought process for you in your head. I need, A is 1, right? 1 right there. So I need factors of 18, two numbers that multiply to a positive 18, add to negative 11. So I know that 9 and 2, this is the first one that came to my mind, 9 times 2 is 18. I am looking to multiply to a positive 18, but add to a negative 11. Remember, when C is positive, both factors are positive or both factors are negative. So to add to a negative 11, I need this to be negative and this to be negative. Is that okay? Let's see. Negative 9 times negative 2 is a positive 18. When I add these together, I get the negative 11 that I needed. So my factored form is z minus 9, z minus 2. I always put the little slash through my z's so that it doesn't look like a 2 by accident. Number 6, b squared plus 9b minus 10. A is 1. This is a quadratic, so I need factors of negative 10 that add to 9. My first thought is 2 and 5. Because this is negative, one of these has to be negative. Not helpful for me, right? That's either going to get me a 3 or a negative 3, so this guy is out. What else gets me 10? I could think about 10 and 1. This is negative, so one of these has to be negative. And to get to a positive 9, I need 1 to be negative. So my factored form is b plus 10, b minus 1. Number 7, x squared plus 6x minus 15. A is 1, so I need factors of negative 15 that add to 6. First thought is 5 and 3. 5 times 3. It's 5 times 3 is 15, right? This is negative, so I get to have one of these be negative. I meant to put that in green. Let me keep it consistent. If one of these is negative, that's either going to get me a 2 or a negative 2. So that's not helpful. And then I've got 15 and 1. One of those being negative gets me 14 or negative 14. Are there any other factors of 15? There aren't any. So we do not have any factors of negative 15 that add to 6. So we say not factorable, or that's also called prime. If it's not factorable, it's prime. But you can either write this or this. Okay, your turn. Please press pause, and you're working on 8 through 13. When you press play, we're going to check answers for all of them. So please, for real, press that space bar, press pause now, and give these a try. Welcome back. Let's check our answers. So 8. So tempting to say -5, -2, or yeah, that option, right? Because -5 and a -2, when you add them together, would get you -7. But notice this is a -10. So one of these has to be positive, one of these has to be negative, which means this is the only option you've got. And neither of those is going to work, right? Because that either gets you -3 or 3, which is not what you're looking for. So that's not factorable, it's prime. Because there's nothing else that's going to work, right? Other than 5 and 2, you've got 10 and 1. Not going to help. Number 9, difference of squares. And number 10 is x minus 12 times x plus 2. Note, -6, so let me add this to the list. Maybe you thought about 6 and 4 first, where you would want both of these to be negative, but that can't be, right? It's tempting because -6 times -4, -6 plus -4 gets you the -10 you're looking for. But when you multiply them, -6 times -4, that's a positive 24. C is negative, so you need one positive, one negative. Keep looking. So the set of factors that works for us here is -12 and 2. -12 times 2 is -24, and when you add them together, ta-da, you get the -10 you need. 11, factors to be x plus 5 times x plus 4. 12, x minus 5 times x plus 1. And then one more difference of squares example. The one piece I do want to talk about, order does not matter. So like if you wrote this one as x plus 4 times x plus 5, that's completely fine. This one could be x plus 1 times x minus 5. 100% correct. And this one you could write x minus 7 times x plus 7. That would be correct. The one piece that's not optional is the signs. Like this is x plus 1. This needs to be x plus 1, right? The signs matter, but the order of the factors themselves, that could be either one first. It's completely correct. Nice job on these. So our class practice is on page, let me see here, page 48. So class practice is page 48. I will put the answer key to this in today's green folder. I would ask that you work with a partner on it, and then you can check if there's one that you guys aren't agreeing on, you can always check in with me in the key that's in the folder. But work with a partner on this, please. And then homework tonight is page 49. So if you finish the class practice early, by all means, and you've checked your answers, go ahead and jump into tonight's homework, which is page 49. Great job, everyone. I hope you have a fantastic rest of your day.